Hi, this is Alex from devstories.eu. LlamaIndex Context-Augmented LLM Applications, Episode 10 of 14. Built-in agent orchestration is great until your business logic starts looking like a plate of spaghetti. When standard handoffs fail to capture your highly specific scheduling rules, abstractions become a blocker. That is exactly when you need custom multi-agent planners. A custom planner is your power user escape hatch. It allows you to build your own orchestration loop from scratch using a standard LlamaIndex workflow. Instead of relying on a pre-built supervisor to dictate which agent acts next, you control the entire scheduling process imperatively in Python. You dictate the execution order, the data routing, and the state management. The process usually starts inside a custom class, often called a planner workflow. The first phase is planning. When a user submits a request, your workflow sends a prompt to a large language model. This prompt includes the user query and a strict description of the tools or agents you have available. You explicitly instruct the language model to generate a step-by-step plan in a highly structured format. For example, you might tell the model to wrap every action inside an XML block using step tags or format it as a JSON array. When the model replies, you parse that structured output. You use a library like Pydantic to validate the XML or JSON and convert it into a concrete list of tasks that your code can iterate over. Now you enter the execution phase. This part is entirely up to your custom logic. Your workflow iterates through the parsed list of steps one by one. For each step, it checks the requested action. You use standard conditional logic to decide what to do next. If the parsed step specifies a research task, your code explicitly calls your research agent. If the next step requires calculation, you trigger your math agent. Here is the key insight. Because you're writing the loop yourself, you maintain complete ownership of the state. You typically create a shared context dictionary that lives for the duration of the workflow run. When your research agent finishes its task, your workflow takes the result and writes it directly into that dictionary. When the next step triggers the math agent, your custom logic can pass it the exact required data from that shared dictionary. You're not hoping a black box orchestrator passes the right variables. You explicitly map the outputs of one agent to the inputs of the next. Once the loop completes all the steps in your validated plan, your workflow performs any final formatting and returns the answer. Building a custom planner means you trade out-of-the-box convenience for total control. If an agent fails, you can write custom retry logic for that specific step. If a step needs external API validation, you can pause the loop. You're writing standard imperative code that just happens to use language models as functions. The ultimate value of a custom planner is predictability. By forcing the language model to generate a rigid XML plan and executing it with standard Python loops and dictionaries, you eliminate the guesswork of black box orchestration entirely. That's all for this one. Thanks for listening, and keep building.